In question 8, we're told that the complex number w has modulus root 2, so we know modulus of w is equal to square root 2, and argument of negative 3 pi over 4, so we know the argument of w is equal to negative 3 pi upon 4. And we're told the complex number z has modulus 2, so modulus of z is equal to 2. And we're told that the argument of z is negative pi upon 3. Find the modulus and argument of wz, giving each answer exactly. So modulus of wz. Well, what do? Well, we know this is just going to be the modulus of w times the modulus of z. That's just going to be 2 root 2. What about the argument of wz? Well, again, we know that this is going to be the argument of w plus the argument of z. So this is going to be minus 3 pi upon 4 plus minus pi upon 3. So what does that give us? Minus 3 pi over 4, so this is 9 pi over 12. So let me just do this. Minus 9 pi over 12 plus minus 4 pi over 12. So we get minus 13 pi over 12. And of course, this is now outside of the principal range. So we change this, we add 2 pi to this, and we get 11 pi upon 12. Alright, so the next part. By first expressing w and z in the form x plus iy, find the real and imaginary parts of wz. So what do we know? We know w is equal to, and again, we know its modulus is root 2, and its argument is minus 3 pi over 4. So I'm going to write it in trigonometric polar form. So what's this? Well, cosine 3 pi over 4. Again, we can use our triangles to help us here. Minus 3 pi over 4, or even just cosine of 3 pi over 4, would be the cosine of this angle, which is this one in here. So this is pi upon 4. And so this would be a 1, 1, root 2 triangle. But of course this is minus 1. So cosine of 3 pi upon 4 is minus 1 over root 2. So we get root 2 minus 1 over root 2 plus I, and then you can see sine pi upon sine 3 minus 3 pi upon 4. Oh, sorry, minus 3 pi upon 4. This is 3 pi upon 4. But of course, sine minus 3 pi upon 4 is minus sine of 3 pi upon 4. So this is just actually going to be minus 1 over root 2 as well. And please feel free to go and check these. So the answer here is minus 1 minus I. That's what W is. And if you think about the location of W on the Argand diagram, argument root 2, angle minus 3 pi upon 4 means that this is the angle in here. Square root 2, that means that must be 1, or minus 1 rather. And this one also must be minus 1. So that makes sense, right? Minus 1 minus I. So we're good. What about Z? Z is going to be 2, then cosine, and its argument was minus pi upon 3, plus I sine, minus pi upon 3. And again, I'm going to make use of my triangles here. So what is minus pi upon 3? So this will be a, sorry, I've not quite got this right, but if this is pi upon 3, this is 1 to root 3. And again, sorry, I've not quite drawn this the proper way. So this would actually be minus square root 3. So cosine of minus pi upon 3 would be 1 over 2. So this is 2 times 1 over 2 plus I, and then you can see the sign would be minus 3 over 2. Minus root 3 over 2, sorry. So our final answer would be 1 minus I root 3. So now that we've got that written out into their real and imaginary parts, what are we going to do? Well, now we're just going to evaluate what is WZ. WZ is minus 1 minus I, 1 minus I root 3, and we just expand this as per normal, so we would get, I don't need that. Ah, yikes, what's happened there? Okay, there we go. So I would get, sorry, 1 times minus 1 is minus 1. Minus 1 times minus I root 3 will give me plus I root 3. Minus I times 1 will give me minus I. And minus I times minus I root 3 will give me minus plus I squared root 3. And you can see that that is going to be, so this is just going to be minus 1, so this will be minus 1 minus root 3 plus I, and then if we factor out the I, we would get root 3 minus 1. So to find the real and imaginary parts of WZ, so that means the real part of WZ is equal to minus 1 minus root 3, and the imaginary part of WZ is equal to root 3 minus 1. Hence show that sine pi upon 12 is equal to root 3 minus 1 over 2 root 2. Well, we need to do this with the aid of our Argand diagram. So if I draw this Argand diagram out, which I haven't done very neatly, I'm sorry. Not that easy on a computer, I'm afraid. This is the imaginary part, this is the real part. Where is WZ going to be? Well, WZ, if you recall, had modulus 2 root 2, argument 11 pi upon 2. So it's going to be somewhere, sorry, quite right, it's going to be somewhere about here. This would be our vector WZ. This angle in here is 11 pi upon 12. This vector in here is just then pi upon 12. Right? And we know a little bit more than that. We know something about both the real and the imaginary parts. Okay, so what can we say? And we can just bring that back up. The real part is minus 1 minus root 3, and the imaginary part is root 3 minus 1. What does that mean? Well, let's take a look at this triangle, and let's just draw it out one more time. Maybe we'll use a different color for this. So if we were to just look at this as a triangle, where this is pi upon 12, well, what would this length up here be? This would just be the length of the real, the distance along the imaginary axis. So this is just root 3 minus 1. This distance along here is the distance along the real axis, so that's just going to be 1 plus root 3. And we already know what the hypotenuse is because the hypotenuse is the modulus. And so that's going to be 2 root 2. So what can we say about sine pi upon 12? Well, from this diagram we can say sine pi upon 12 is equal to root 3 minus 1 over 2 root 2. And we're done. So that's our QED.